Bismillahirrahmanirrahim. Assalamu alaikum. This is Dr. Noshin Tariq Siddiqui. Today is our second lecture of rheology. I've described you in rheology what are the basics. I've started from the very basic, that is what are basically elastic and non-elastic liquids, what are basically elastic, pseudo-elastic, pseudoplastic or pseudo-elastic liquids, and why they are like that. We have also learned what is Newton's law for viscosity. We have touched viscosity and what is the Newton's law of viscosity and Newtonian. Now we are going to do what are Newtonian and non-Newtonian fluids. Basically, how we classify fluids on the basis of rheological behavior. There are of two types of fluids, basically, which according to rheological behavior of a liquid. Okay, there are of two types. One liquid are those liquid which behaves like what Newtons have described, or what Newton describes, or they follow Newton's law. So they are known as Newtonian fluids, while there are certain other type of fluids which they do not follow the Newton's law, and they basically have other type of property, or they have other type of properties which because of which they are known as non-Newtonian, and they are further divided into time independent and time dependent fluids. Okay. Basically, what Newtonian and non-Newtonian fluids are. If I'll give you example, maybe you have certain idea. The example of Newtonian fluid is water, milk, even syrups like honey are Newtonian liquids. While for non-Newtonian, the most famous example is the cornstarch. Water and cornstarch mixture is the non-Newtonian fluid. What happens that if in Newtonian fluid, the viscosity remains constant. If you apply any force, then the viscosity of the fluid, it remains constant. While for the non-Newtonian liquid, when you apply force to a non-Newtonian fluid, it behaves like a solid. Of course, this is a very strange behavior, how a liquid can behave like a solid. This is something, different. But, it is caused because the solid particles and the particles in the non-Newtonian liquids, they, behave like, or they start behaving like a solid. While in, in Newtonian fluid, if the viscosity is high, you can say the movement is slow, or the viscosity is low, the movement of the fluid becomes high. As you can see in honey, if there is a cold honey, then if it is high viscosity, then the movement of the honey when it is in a cold state, it is difficult or it is slow. But if you heat that honey, then it, the viscosity lowers and the movement becomes high. But if you put some pressure on honey, means that temperature has an effect on the viscosity. But if you put any pressure or force on honey, there will be no effect on its viscosity. No matter how much pressure you have applied, then there will be no change in its viscosity. That type of liquids are known as Newtonian liquids. While in cornstarch, it is, when you apply force, then then their viscosity, alters their viscosity. The force alters its viscosity. And then they resume, certain time they resume the original state, and certain times they don't resume that state. That's why they are of different types, time dependent and time independent. The example may be cornstarch and ketchup and mayonnaise, etc. For Newtonian liquid, you have a classic example that is water, and the water has a predictable viscosity changes that you can only change the viscosity with change of temperature and change of pressure. But if you apply force, then there will be no change. Okay. Viscosity is basically, it is one of the aspects in rheology. Why? Because it is a measure of fluid resistance to flow by an applied deformation. Basically, it is a measurement of how the fluid is resisting to flow by an applied force, which is also known as deformation force, or by shear stress. What is shear stress? There are different types of forces, which you can apply. I'll describe it later, but right now you should, just keep in mind it's like that. If you rub your hand, okay, the force you are basically putting in rubbing your hand is basically a shear stress. Viscosity basically describes the internal friction of moving fluid and therefore its thickness. Basically, it is describing the internal friction of a moving liquid, the viscosity. For example, I've given you an example of honey. Honey has internal friction, so its particles basically, they do not, they hinder and they are concentrated, the particles, so the honey resists to flow. Okay, while water don't resist. So the viscosity of a liquid, basically it depends on certain things. Number one is the chemical structure. As we have seen, there is a chemical structure difference of honey and water. Chemical structure, so the viscosity is different. We are only right now describing the viscosity. We are not concerning with Newtonian and non-Newtonian fluid right now. Okay, I'm only describing you what is viscosity. So while water, a liquid viscosity depends upon what? Its chemical structure, its morphology, and the attraction of force between the molecules, its molecule. Okay. The essential elements, among these essential elements, there are other things as well. What are those? A fluid or a material, it is, it can be pulled apart, or you can force it together, or you can I've told you, you can put, you can have shear, or you can slide that thing over one another. That is called shear. Okay, there are different type of deformation or flow behavior, we can say. Right now, I have described you the material which can be pulled apart, or pulled apart is kind of its tension, or forced together, compression, or bending. That is, if you put pressure on different positions and you apply pressure on a thing from a different sides, then it's bending and torsion and shear. How you are going to describe what is shear rate and shear behavior, shear stress. What is a shear rate? If you can see, if you take a pipe, okay, and in that pipe, you see water is flowing through that pipe. You see there will be a flow difference if water is running with equal force. Okay, so the rate through which the water is flowing from the part which is red in color, in both these colors, the middle of the pipe and the area which is closest to the internal surface of the pipe. So the rate through which both the flow rate in the middle of the pipe and the area which is nearer to the inner wall of the pipe, the flow will be different. Or we can say that a velocity gradient will be different. Okay. The liquid layers do not flow equally with equal velocities throughout the pipe. There will be friction between pipe wall. Why they are not flowing equally? Because there will be a friction between the pipe wall. So the rate will be different there. And the intermolecular attraction of the liquid, because of that, the rate will be different in the middle layer as well. And the difference between these velocities is known as the shear rate. You should always you should remember that what is shear rate? The difference between these two movements is the shear rate. And now what is shear stress? How much you have applied that stress? Force that is applied over a given unit area. If you consider it a unit area, the force which is applied to this given area is known as shear stress. If you increase shear stress, shear rate is increased. So they are kind of directly proportional to each other. Increase shear stress increases shear rate in given you can say in a given area. Okay, so more viscous, then more force is required, and if the liquid is less viscous, then a less is required. So there is a basically there is a correlation between viscosity and the shear stress and shear rate. After which, the viscosities, the of a material is derived, which I will, I will share it with you later, that what is the basically the relationship through that. Okay. Now we'll come to the topic, what are Newtonian fluids? Now you have idea what is shear rate and what is shear stress. Okay. The force, basically the force you are applying is shear stress, and the rate through which the fluid is moving is shear rate. Okay, you keep that in mind. And the viscosity as well. Okay. Now, what is Newtonian fluid? Simple liquids, either pure chemicals or solutions of lower molecular weight, because I've told you that everything depends on viscosity of a substance. So morphology also is there, the internal structure is also there. Okay, so you keep in mind that simple liquids, either pure chemical or solutions of lower molecular weight compounds, are Newtonian fluids in which a direct proportionality exists for all values of shear between shear stress and shear rate. In Newtonian liquids, there is a direct proportionality of these two things, that is the shear rate and shear stress. The shear stress increases, the shear rate will increase. So there will be a direct proportionality. They are directly proportional. What is going to be the viscosity? Viscosity of such fluid is independent of the rate of shear, but dependent on composition, pressure, and temperature. The viscosity will not be dependent on the shear. Okay, the viscosity will be independent of the rate of shear, how much force you are applying. Viscosity will not change. So but depends on only its composition, its pressure, or the pressure you have applied, and the temperature if you can apply. Only that can change its viscosity. Nothing, the force cannot. Okay, so that type of fluids are known as the Newtonian fluids. Okay, what are other aspects? through which you can, understand what are Newtonian fluids, are the rheogram and viscogram. Rheogram and viscogram, in rheogram, you basically plot diagram between the shear stress and shear rate, while in viscogram, it's against viscosity and shear rate, okay? For Newtonian fluid, the rheogram is linear and passes through the origin. For Newtonian fluid, what is the rheogram is linear. It is a linear graph and it passes through the origin. It starts from the origin, basically, from the zero unit, you can say. Okay, when there's shear stress and rate, both are at zero. Okay, indicating that minimal shear applied will induce shear. If you apply a minimal stress, minimal force, then a minimal shear rate is also going to be observed. The slope of such a curve is fluidity. Basically, if it is increasing, the fluidity increasing, and if we see the same graph, the slope, inversely, then it's the viscosity. Viscosity increases and decreases. Okay. Shear stress and shear rate are directly proportional, and therefore a single viscometric point can characterize the liquid rheology. For Newtonian fluid, the viscogram is a straight line. Why this is a straight line? Because there is no change in viscosity with the rate of shear, indicating the Newtonian viscosity is independent of the rate of shear. You see, the one is the rheogram. It has a linear line, while in viscosity, it is constant. Even if the rate of shear is increasing, the viscosity will remain same. The absolute viscosity of some Newtonian liquid or pharmaceuticals interest are given in 3.1. This is the table 3.1. I have taken this from a book, so the all the tables are there because the chapter was the third chapter, so that's why it's the tables are according to that. Okay, so you can also say this is table 1 as well of rheology. Okay, the absolute viscosities of Newtonian liquids at 20 degrees centigrade. Why? Because temperature has effect. Okay, so we have considered its absolute viscosities at temperature 20 degrees centigrade. Liquid like ethyl ether, it has absolute viscosity of 0.24. Acetone has 0.34. Chloroform water, you can say, you can remember these, that at normal temperature or at 20 degrees centigrade, how are their viscosities. You can also determine viscosity of different liquids like that. What are non-Newtonian fluids? Non-Newtonian fluids are fluids with no direct linear relationship between shear stress and shear rate. They don't have a direct effect like the Newtonian fluid. That is, they do not follow Newton's law of flow. They do not follow Newton's law of flow. The rheological behavior of non-Newtonian fluids may be characterized as either time independent or time dependent. सबसे पहले करेंगे time independent non-Newtonian fluids. Okay, these fluids instantaneously adapt the changing shear. What are these? What are time independent? These fluids instantaneously adapt to changing shear stress. They basically, what they do, they adapt to the shear stress or the force you are applying. They basically change. Okay, the fluidity changes. Time-independent non-Newtonian fluids behavior can be of three types. They are of three types, that is plasticity, pseudoplasticity, and dilatancy. Okay. Number one is the plasticity. What are the plastic non-Newtonian fluids? Plastic materials or Bingham plastic requires an initial finite force called the yield value before any rheological flow can start. What it requires, basically at a ऐसे जैसे कि रखा हुआ हो खाली कोई भी ऐसा non-Newtonian fluid which is at rest basically. So एक initial force required होती है. That initial force उसको करने मतलब उस initial force के apply करने से पहले वो सॉलिड की तरह बिहेव कर रहा होता है, ठीक है। तो you need, or that force which which you required is known as yield value. Okay. Before any rheological behavior or the flowing behavior starts, you need a finite kind of force. At shear stress values below the yield value, such plastic material substances behave as elastic solids. उस yield value से पहले they basically behave like a solid or elastic solid. Behave as elastic solid exhibiting reversible deformation means if you apply that force under the yield value and उस yield value से नीचे if you apply that force तो वो वापस उसी condition में आ जाते हैं. Okay. Elastic flow exhibit reversible deformation and above the yield value they behave as Newtonian system. और उससे ऊपर दे अगर आपने yield value से ऊपर अगर आप force apply करते हैं तो they will start behaving like a Newtonian system. Concentrated flocculated suspensions जो है वो उसकी एक मिसाल है concentrated flocculated suspensions. Example, concentrated zinc oxide suspension in semi-solid dosage forms such as gels, creams, and ointments are the examples of plastic materials. How are they rheograms and viscograms? The rheogram of a Bingham plastic is represented by a straight line or curve on this stress shear rate plot being displaced from the origin by the yield value. The slope of the linear portion is known as mobility, which is the inverse of plastic viscosity. You see? ये जो yield value ना in between ये जो yield value आपको ये straight line आ गई, this is the force which which is required. इससे पहले तक the material will behave like an elastic solid. Okay. इसके बाद it will behave like a Newtonian fluid because it's a linear line है ना. Okay. But अगर आप इसको देखो तो viscosity क्या होती है कि after applying certain shear rate, its viscosity decreases. Okay. What is the reason? Basically, plasticity is often exhibited by a concentrated flocculated suspension where particles are attracted by the force of flocculation, which is known as van der Waals forces. The forces which is between the two molecules. Okay, these are known as van der Waals forces. The shear force required to break the force of flocculation between the particles contributes to the yield value. जो flocculated जो आपके molecules हैं, जो particles हैं, जो flocculate हुए हैं आपके किसी suspension के अंदर, उनके दरमियान क्या है? van der Waals forces है. उस van der Waals forces को तोड़ना basically ताकि उससे उस force से वो बाहर आ सके और flow कर सके, उसको basically क्या कहते हैं? हम yield value कहते हैं. Okay. The shear force required to break the force of flocculation between the particles contributes to yield value. Continued shear breaks further linkages, thus leading to decrease in apparent viscosity. और अगर आप continue करें उसको break करना उसी van der Waals forces को, तो वो क्या होगा? Viscosity decrease होना शुरू हो जाएगी. सही है? Continued shear breaks further linkages, thus leading to the decrease in apparent viscosity with the increase in shear. Shear rate. On exceeding the yield value, the shearing stress and rate of shear becomes directly proportional, and the diagrammatic explanation of plastic behavior depicts in 3.5. This is, how it is done. The first क्या होते हैं? Floccules बने हुए होते हैं. They are attracted towards each other because of the van der Waals forces. ठीक है, जब आप yield value उसको provide कर देंगे इतनी value जो कि उसको move करने में मदद की और जो उसके van der Waals forces से ज्यादा हो. ठीक है, तो फिर क्या होता है कि आपके जो flocculated जो आपके at rest position पे जो आपके suspended particles हैं, they start to separate out. Okay. So this is the diagrammatic representation of the plastic flow. What is pseudoplasticity? Pseudoplasticity is basically shear thinning behavior is often referred to as pseudoplasticity. जो shear thinning behavior होता है, that this is also known as pseudoplasticity. Pseudoplastic materials tend to become more fluid the faster they are stirred. They get more fluid-like when they are stirred very fastly. Weakly flocculated suspensions, polymeric solutions such as solution of tragacan, sodium alginate, cellulose derivatives, and semi-solid systems containing polymer components are example of pseudoplastic material. How will be its rheogram and viscogram? Rheogram begins at the origin, indicating that the particles bond are too weak to withstand the applied shear stress. The increase in the rate of shear is greater than the corresponding increase in shear stress, resulting in the rheogram being a curve, being a concave towards the shear rate axis. A decrease in viscosity is observed with increase in shear rate. If you see why this is a curve, because shear stress से shear rate भी increase होगा, but एक time ऐसा आएगा कि वो इतना फ्लूइड हो चुका होगा कि उसके ऊपर shear rate के ऊपर इतना फर्क नहीं, shear stress भी प्रोवाइड आप मतलब उसके बाद अब अगर प्रोवाइड करते रहे ना मजीद फोर्स भी आप, तब भी जो है ना तब उसके फ्लो पे नहीं फर्क पड़ेगा, फ्लो उसका इंक्रीज होता रहेगा, रेट का shear rate इंक्रीज होता रहेगा, लेकिन फोर्स आप कितनी भी अप्लाई कर लोगे तो वो हो चुका होगा, ठीक है, तब तक वो इतना फ्लूइड हो चुका होगा. विस्कोसिटी ऑफ कोर्स जैसे जैसे आपका shear rate आप जिस रेट से बढ़ाते चले जाओगे आपकी विस्कोसिटी कम होती चली जाएगी. Okay? Now what is the reason? Basically क्या होता है कि pseudoplastic flow is exhibited by polymeric solution. Basically ये जो solutions होते हैं, these solutions are made up of polymers. Okay, the बड़े बड़े big polymers होते हैं ना, ठीक है, वो मतलब समझो कि polymers आपस में एक दूसरे के साथ entangle हुए ना, बड़े बड़े polymers. In polymeric solutions, the flexible long chain macromolecules are in the thermal agitation with water